Good morning, one and all. My name is V. Abhijit Kumar. I'm studying in BTech first year, second semester, CSC, AI, ML, that is Computer Science and Engineering, with a specification of Artificial Intelligence and Machine Learning, Institute of Aeronautical Engineering. In this concept video of the subject of AP, that is Applied Physics, I am going to explain about the topic of monoclinic lattice. Now, first of all, let's go through the contents which I'm going to explain about in this presentation of mine. In the first place, I'm going to introduce this concept of crystal systems, and after that, I'm going to explain what is a monoclinic lattice, and after that, I'll explain about the unit cell of monoclinic lattice, and after that, I'm going to explain about the properties of monoclinic lattices, and there are certain examples of monoclinic materials, and I'm going to explain about them after that. And after that, applications of monoclinic crystals, I'm going to explain about them. And after that, finally, I'm going to conclude this concept of monoclinic lattices. Now let's go through the introduction to crystal systems. The first thing is that the crystals are classified based on their unit cell geometry, which means that the crystals are grouped by the shape and angles of the smallest repeating unit in their structure. The 7 crystal systems, which are cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and rhombohedral, are present in the concept of crystal systems in the subject of applied physics. These 7 systems represent all the possible ways in which atoms can be arranged in any given 3-dimensional space or 3D space, whatever we call it, to form the different types of crystals. And after that, monoclinic lattices or monoclinic crystals is one of the most distinct and widely studied systems. The monoclinic systems are unique, very unique, because they have unequal edges and one non-right angle, making it important in many kinds of mineral studies. Hence, this is the introduction of the concept of crystal system. Now let's go through the question about what is a monoclinic lattice. Any crystal system is characterized by 3 unequal axes and 2 axes at right angles with the third axis inclined. This monoclinic lattice specially has this kind of systematical arrangement. Let's consider the lengths of axes as A, B, and C. In this scenario of a monoclinic lattice, these 3 are unequal. Axis lengths A is not equal to B, and B is not equal to C, and vice versa. A is not equal to C, whatever we call it. And the angles, we consider alpha, beta, and gamma as the angles, the 3 main angles in this lattice. These angles are measured or considered to be in this way. The angles alpha and gamma are equal to each other. That is, the alpha is equal to gamma is equal to 90 degrees, but beta is not at all equal to 90 degrees. It can be 180 degrees, it can be 70 degrees, whatever we consider. Hence, this is the concept of monoclinic lattice. Now let's go through the unit cell of monoclinic lattice. In the first place, I have already told about the monoclinic lattice. The illustration of monoclinic unit cell is, as you can see in the background image, it is a cube type of shape, as we all know, the skewed angle in between gives a distinctive parallelogram face, and it is of two types: simple monoclinic primitive, and after that base centered monoclinic, which is also called C-centered. Hence, these are the two types of monoclinic lattices. Hence, this is the unit cell of monoclinic lattice. Now let's go through the properties of monoclinic lattices. These monoclinic lattices have four properties. The first property is anisotropic behavior, which means that these monoclinic lattices have properties which vary with their directions. And after that, these monoclinic lattices have lower symmetry compared to cubic or tetragonal systems, which means that these monoclinic lattices are not very symmetrical. They need not be always symmetrical. And after that, the next property is that these monoclinic lattices are commonly found in minerals and organic compounds. And the fourth property is that these monoclinic lattices are unique and mechanical and optical and very thermal. These kind of characteristics are obtained only and only in monoclinic lattices. Hence, these are the properties of monoclinic lattice. And now, let's go through the examples of monoclinic materials. These monoclinic materials can be given a lot of examples. I have chosen 5 important examples out of many of those examples. The first one is gypsum, or CaSO4.2H2O, whatever we call it. And after that, orthoclase feldspar, and after that, borax, and after that, monoclinic sulfur, and after that, pharmaceuticals. A lot of pharmaceuticals are available, out of which one is paracetamol. Hence, these are the examples of monoclinic materials. Now let's go through the main applications of monoclinic crystals. These applications, as usual, we know that there are a lot of applications of this concept of monoclinic crystals in the world. I have chosen only 4 of them to explain. The first one is optics. These monoclinic crystals are birefringent materials, due to which they can be implemented in the concept of optics. And after that, electronics. These monoclinic materials are simply piezoelectric materials. These piezoelectric materials can be easily applied into the concept of electronics. And after that, mineralogy. The study of Earth's crust compositions can easily implement the concept of monoclinic crystals. Hence, these monoclinic crystals can be easily implemented as per the concept into the concept of mineralogy. And after that, as discussed before, pharmaceuticals. The stability and solubility studies can easily implement the concept of monoclinic crystals. Hence, these are the applications of monoclinic crystals. And now finally, I would like to conclude this topic. Hence, this monoclinic lattice is an essential topic in the study of crystal structures. Its unique geometry leads to important industrial and scientific applications. Hence, the topic of monoclinic lattice is concluded. And finally, I would like to thank the respected professor who had given me this wonderful opportunity to speak upon this wonderful topic. Thank you.